Guys, Cody Shire here with Advanced Power Quality. Today I wanted to talk to you about solar. I wanted to talk to the residential customers out there that are thinking about going solar at their house, possible rooftop installations, and I also wanted to talk to the system planners out there that are seeing a lot of subdivisions that are requiring their residents to install solar panels. How that may affect your feeders and what to do about it. So jumping into it, I wanted to first touch on the residents that are considering rooftop installations. So I get a lot of time, Cody, I'm gonna install solar panels on my roof. Well, one thing to think about is whenever you actually have to replace your roof, every 10, 15, 20 years, you not only have to replace the roof, you have to take off the solar panels, replace the roof, put the solar panels back on. Now, if this isn't done properly, essentially all the hardware for the solar panels, you're drilling into the roof. If it's not sealed properly, you can run into leaks through the roof. Just an item to consider. The next subject I want to speak on is a safety concern for our troublemen and linemen out there. So solar panels essentially work as a generator. They backfeed our utility lines and can energize them. Well, during outages and such, if the residential customer doesn't have a cutoff switch properly installed, that backfeed can energize the lines that our troublemen and linemen are working on. It possibly could cause danger to them. The next subject, I get a lot of times, hey Cody, I bought this 1 kW solar panel. How come I'm not seeing 1 kW? Well, that's perfect scenarios. No cloud cover, no dust, no pollen on the panels. Panels are exceptionally clean, no tree cover, shadows of any kind. Real world scenarios, you're gonna have all these items. You're gonna have cloud cover, you're gonna have pollen, dust on the panels. You might see 80 to 85% real world conditions. So don't expect what you buy and what's advertised to be 100% correct on those aspects. Now, I'm going to move into our electrical engineering aspect, our system planners out there, some items to think about, and the residential customers, feel free to watch this also, as it may open your eyes into some aspects that you may not realize that solar imposes on your distribution system. So our system planners, whenever you see a large solar farm or a large subdivision requiring residents to install solar panels, this may impact your protection scheme actually. So what I mean, for instance, is our protection scheme is all it's all fault current based. It's all based off of fault current, magnitude, and duration. So currently right now, it's all based as if fault current was provided from one source, the substation. So typically you'd have the substation, you'd have your backbone feeder, you have your laterals, your breaker, recloser, let's say 100 amp fuse, 80, 50, and 30. Well, they're gonna blow accordingly as if the fault current was provided from the substation. Now, what happens whenever you introduce a solar farm at the end of that lateral line? Well, you can have some backfeed of fault current provided from that source, and you can have fuses blow incorrectly. Now, that doesn't only throw off your protection scheme, it also throws off your troubleshooting scheme. So what I mean by this is our typical troubleman, they'll get a call, or dispatch gives them a call, hey, these people are without power. Well, the troubleman goes behind that fuse, that lateral line, and they start patrolling for issues. And they're looking for issues downstream from that fuse, when in reality, it can be upstream. This next item, sectionalizers. So sectionalizers work off of a count system. Essentially, whenever they sense zero current, they do a count. And this would work properly if you had substation, you had a breaker at the substation, you had a recloser, and you had a sectionalizer, let's say. Well, breaker trips, recloser trips, sectionalizer counts. Well, whenever you have a solar farm or solar backfeeding the system downstream from there, that sectionalizer is never going to count zero if it's sensing that backfeed. So your sectionalizers are essentially useless in that scenario. This next topic I want to speak on is rather large. So at a previous utility I worked for, we did a large study when natural gas prices got extremely low, and a lot of the natural gas power plants and turbines were being introduced. Due to your typical natural gas turbine is a lot smaller than your coal fire or anything like that. To say this, it's in reference to the rotational mass of the turbine. So what I'm getting to is your voltage stability out there on your distribution or your electric utility is your rotational mass. So power plant works, you have a turbine, it's continuously moving. That rotational mass of the turbine is your voltage stability. Well, solar doesn't have that. You have essentially no voltage stability with solar. And what this means is you have your power plant, your power source, you have a customer downstream, they fire on a 3,000 horsepower motor. Well, what happens? Well, current goes up, voltage goes down. Your rotational mass at the power plant is your voltage stability. If you induce solar there instead, it could run into a lot of issues. The next item while we're on voltage, so I want to talk to you about voltage levels. So essentially utilities, they have all sorts of voltage controlling devices. They have LTCs, low tap changers at the substation. They have capacitor banks, regulator banks. They have reclosers that sense voltage and communicate. They have all sorts of SCADA systems that provide them this data, and all these systems interact accordingly to essentially regulate the voltage levels on the system. So they're all talking, hey, do I need to turn on? Do I need to turn off? Do I need to step up? Do I need to step down? Well, whenever you induce backfeed into the system that is not a part of that communication, you can have these systems essentially react not knowing how it's going to affect this system here, the solar backfeed. So you can run into some higher voltages and such as that. Now, to say all this, I'm not against solar. I think solar is a great idea, and I'd love to see it go further. Some items to consider to get around this is the utility offering a communal solar farm. Residents buying into the communal solar farm and reaping the benefits. That way the utility can monitor and plan their voltage controlling devices and their protection scheme accordingly to get around these items. But yeah, that's some items I wanted to discuss on solar. And thanks again, guys. If y'all have any questions, leave them in the comments. If you have any suggestions for other videos or next videos, leave them in the comments. And thanks, guys. Have a good one.